Hello again. In this example, we have a positive 12 microcoulomb charge is placed at the origin. A second negative 12 microcoulomb charge is placed 5 meters to the right of the first charge, which means this is our positive 12 microcoulomb. That's a negative 12 microcoulomb, and the distance here it is 5 meters. Now, what is the net electric field at point P? So this is our point P here, and it says assume it is equilateral triangle, which means the distance here also is 5 meters, and also here it's a 5 meters. I'll call the positive one as a Q1, the negative 12 microcoulomb, it will be our second charge. Now, to calculate the electric field generated by the first charge, it's a K Q1 over the distance 1 square. That will be 8.9 10 to the power 9 multiplied by 12 microcoulomb and divided on the distance squared. That should give us 4.27 10 to the power 3 Newton per coulomb. Now, to decide the direction of the electric field generated by the first charge, well, our tested charge, we said it is a positive charge. We said that in our previous videos, and this is another positive charge from Q1, and that will make the electric field 1 goes this way. That's E1. Now for electric field 2, which is the one generated by the second charge, it will be the same value of the electric field 1 as a magnitude, because it's the same distance, the same magnitude of charge, which means it will be 4.27 10 to the power 3 Newton per coulomb. But the direction of the electric field 2 will not be the same, as it is a negative charge Q2 that will make the E2 going downward this way. Okay, so we managed to calculate the magnitude of electric field 1, the magnitude of electric field 2, decide the direction of electric field 1 and 2. Now, to find the net electric field at point P, we should analyze our electric field vectors. Try to change the color. So for E1, I will have E1x, and also here it will be E1y. Let's pick another color. Maybe we take blue for the electric field 2. That will make it E2x, and then E2y. Okay. Now we can write them down quickly. So E1x, it will be E1 cosine 60 degrees. E1y will be E1 sine 60 degrees. For E2x, it will be E2 cosine 60 degrees. For E2y, it will be E2 sine 60 degrees. But whatever the value or the magnitude of E2y, it will come as a negative, because it's going downward, or it's going to the south, or the negative y-axis. So, but you can see, because the magnitude of electric field 1 and the electric field 2 is the same, and we're using the same angle, you can terminate for sure the electric field 1 and the y component with the electric field of the 2y component, because they will be equal in magnitude, opposite in direction, which leave us with that. I will end with, that's our charge P, and I will have electric field 1x component and the electric field 2x component, which means the electric field net, it's going to be only on the x-axis. It will be E1x. That's, let's say, the total net electric field on the x-axis. 2x. That will give me, just to be more details, cosine 60 plus E2 cosine 60. They are exactly the same amount, so it's kind of like you times 2. That will give me back 4.27 10 to the power 3 Newton per coulomb. So that will be the total electric field on the x-axis. Now, to find the net electric field for the whole electric field generated by these two charges on the point B, it will be the EX square plus EY square. We said the EY component total will be 0. They cancelled each other. That will leave us with the EX square under square root, and it will give us back again the same value again. All right, that's the way to handle a question like this. That's the details. You follow the instruction, you identify your charges, you follow the formula. We just got the same electric field as a magnitude because it's the same charges in magnitude on an equilateral triangle, so the distance will be the same. You just follow the rhythm of the components. Some of these components, they will terminate each other. The y component, what we leave stay with us, will be the total x component. I hope you find this example useful, and we'll see you in another one. Thank you.